Box on the floor.
Give me number 9.
This is Jewel over here.
Wait, what's going on? Jewel the loser!
Open this box.
Right on my sheet.
We're actually recording the video. Put it on the back of the series. And then copy it down on the Look at Jewel.
Yeah.
Oh, look at Jewel.
This is, what are the
can't pull the box.
three-body diagram of the forces on that box?
Yeah.
Gravity,
Oh, normal.
normal forces up. Friction is which way?
That way.
That.
And there's a row, so there's tension, right? So this one has all of them. And it says it's moving at a constant velocity. What does that tell you? What's the acceleration?
Zero.
Means the acceleration is zero. If the acceleration is zero, what does that tell you about the net force?
Zero.
Zero.
Zero, right? Now in all these problems, this is like what we did with projectile motion. The x-axis, or the horizontal motion, is independent of the y-axis,
You scared me.
which is the vertical. Which means you can write two different F-net equations. So the one that's horizontal, F-net, in the horizontal direction or the x direction. What forces are acting horizontally in this?
Tension and friction.
Tension and friction. If we pick this way as positive, because that's the way it's moving, then this would be, the tension would be positive, but the friction's pointing in the negative direction, right? So this is going to be negative friction force. Everybody follow why that's a negative?
Yeah.
All right. So then, what's the F-net in the vertical direction? If we
Zero.
pick up as positive.
Zero.
What forces are acting? Yes, it is zero.
Gravity and normal.
Gravity and normal forces out if we pick up as positive.
Yes.
So it is equal to 0.
Key to all F-net problems. Replace F-net with.
Tracy like that.
So on this one,
With mom.
this is MA horizontal. This is MA vertical. In this case, both of them are zero, right?
Yeah.
So in this case, they're both zero. So if you solve for it, you get the tension is equal to the friction force, and the normal force is equal to the weight. What can you substitute in for friction force? What's the equation for friction? Coefficient of friction times normal force. What can you always substitute in for the weight? Mass times gravity. This is a substitutable equation. This is a substitutable equation. In this problem, then, you know the tension is equal to mu times F sub n. Well, what's F sub n equal to?
F sub G.
Which is mg. So this whole thing becomes mu mg. And in every case, if it's a level floor, the friction is always mu mg. Nice level floor, that's always the friction. Depends on the mass, depends on gravity, and depends on the two surfaces. So this one, the force that Jewel is pulling with then is mu mg, right?
Yeah.
He's providing the tension in the rope. That's the force that's being applied to the box in his direction. It's being opposed by friction. Those two are equal. And so that's the force he's applying. Number 10, though, says, same problem.
Please excuse this interruption. Varsity tennis team members, please come to the shed at our courts right after the school. The courts at Walkwall are dry, so we'll be playing this afternoon. I repeat, the courts at Walkwall are dry, so you will be playing this afternoon. Thank you very much.
All right. Anyway, this one, now there's an acceleration. Acceleration is 0.85 meters per second squared. What do you replace up here then with that? F net horizontally, the MA horizontal is no longer 0, right? This is MA horizontal is equal to the tension minus friction force, which is still mu mg. And you have to solve for the tension. You always solve for the tension. And you always solve for the normal force. It's always going to be equal to something else. But you have to solve for normal, solve for tension. Okay, so free body diagrams are really useful on all force problems. They're kind of the way you start. And you need to be able to understand free body diagrams, so if you do, you have a good start on force problems.